Good morning, students. I am Mrs. M. Teresa Nirmala from the Department of Mathematics. Today we are going to see about the beta and gamma function. First, let us see the definition of beta function. The beta function is defined by beta of m comma n is equal to integral over 0 to 1 x to the power of m minus 1 into 1 minus x the whole power n minus 1 into dx, where m comma n both are greater than 0. Now coming to the definition of gamma function, the gamma function is defined by gamma of n is equal to integral over 0 to infinity e to the power of minus x into x to the power of n minus 1 into dx, where n is greater than 0. These are the definitions of beta and gamma function. Now coming to the properties and results, the first property is beta of m comma n is equal to integral over 0 to infinity x to the power of m minus 1 divided by 1 plus x the whole power m plus n into dx. Now coming to the proof of this, let us start the proof by assuming let x is equal to y by 1 plus y. Now by cross multiplying, simplifying this, we will get the value of y as x by 1 minus x. Since we made the substitution, the limits will change. Therefore, when x is equal to 0, the value of y is also 0, and when x is equal to 1, our y is infinity. So we are getting the new limits for y. And coming back to the substitution for x is equal to y by 1 plus y, differentiating both sides, we will be, and simplifying this, we will be getting dx is equal to dy divided by 1 plus y the whole square. Now coming back to the definition of beta of m comma n, and by substituting the new limits and for the value of x as y by 1 plus y and for dx as dy by 1 plus y the whole square, and after simplifying this, we will get the answer as integral over 0 to infinity y to the power of m minus 1 divided by 1 plus y the whole power m plus n into dy. Similarly, we can prove it in terms of x, so we got the result. Now coming to the second property, beta of m comma n can be written as beta of n comma m. So this can be proved by making the substitution as x is equal to 1 minus y. So therefore, to get the new limits, when x is equal to 0, value of y is 1, and when x is equal to 1, our y is 0. Therefore, the new limits are 1 and 0. Therefore, coming back to the definition of beta of m comma n, by substituting the new limits and the value of x is 1 minus y and the value of dx is minus dy, will be getting the value as beta of n comma m. So hence we have got the second property. Coming to the third property, beta of m comma n can be written as 2 times integral over 0 to pi by 2 sin x the whole power 2m minus 1 into cos x the whole power 2n minus 1 into dx. This result can be got by substituting x is equal to sin square t. When we differentiate both the sides, we will be getting dx is equal to 2 into sin t cos t dt. So to get the new limits, when x is 0, our t is 0, and when x is equal to 1, t is pi by 2. Therefore, substituting this in the definition of beta of m comma n, will be getting integral over 0 to pi by 2, 2 times of sin x the whole power 2m minus 1 into cos x the whole power 2n minus 1 into dx. Now coming to the fourth property, beta of m comma n can be written as beta of m plus 1 comma n plus beta of m comma n plus 1. So this can be got by this definition of beta of m comma n. Starting with the definition of beta of m comma n, here we are making one substitution that in dx can be written as 1 into dx. In the place of 1, we can write this as 1 minus x plus x. So in the next step, splitting this into two terms. The first term is nothing but beta of m comma n plus 1, and the second term is beta of m plus 1 comma n by using the definition of beta function. So hence we have got the fourth property. Now coming to the fifth property is related to gamma function. Gamma of n plus 1 can be written as n into gamma n. We know that gamma of n is 0 to integral over 0 to infinity e to the power of minus x into x to the power of n minus 1 into dx. So now taking the left hand side, gamma of n plus 1 is nothing but integral over 0 to infinity e to the power of minus x into x to the power of n into dx. This can be written as limit a tends to infinity integral of 0 to a e power minus x into x to the power of n into dx. Now this is of the form integral u dv. After substituting the formula and taking the limit as a tends to infinity, we will be getting n into gamma n, which is nothing but our right hand side. Now coming to the sixth property, gamma of 1 is nothing but 1. Substituting in the place of n as 1 in the definition of gamma function, will be getting integral over 0 to infinity e to the power of minus x into dx. By the ordinary integration and by applying the limits 0 to infinity, you will be getting the value as 1. Now coming to the last property, it is nothing but gamma of n plus 1 can be written as n factorial. Repeatedly by applying the fifth property, you will be getting gamma of n plus 1 is n into gamma n. Once again applying the fifth property, again repeatedly applying the fifth property, will be getting n into n minus 1 into etc. into 2 into 1, which is nothing but n factorial.